Hello again. We've been doing some heat loss equals heat gain problems where you do a chemical reaction, usually a combustion, it releases energy, and then that energy warms up some water. You can do the same thing with a calorimeter, and it's not that different, but of course we're going to have to use the calorimeter formula that we don't see all that often. So they say here we're burning heptane, so we have one thing that's happening is a heptane combustion, and that's going to produce heat. And the other thing that happens is a calorimeter warms up. Calorimeter absorbs that exact same amount of heat, and its temperature rises. So what have they given us for information here? Actually, before we even get to that, when heptane burns, that's just a chemical reaction, so we can use energy equals N delta H to figure out how much energy is involved here. And on the calorimeter side, when most things heat up, we write energy equals MC delta T, but for calorimeters we have a special simplified version that just looks like this. With professionally made calorimeters, they know what the mass is going to be, and so they just bake it into the C value so that you don't have to do it. And now let's look at what information they've given us. They told us here we have 1 gram of heptane, and they actually give us the delta H for heptane, which is lovely. I was just starting to think about writing the balanced reaction, but no need. Enthalpy of combustion is 4816.7 kilojoules per mole of heptane. Heptane is C7H16. We're given its mass. I'm sorry, I was starting to think molar mass, and then got to this. This is our delta H. The molar mass, which we're also going to need, would be 7 carbons is 84.07. 16 hydrogens is 16.16. 3 carry 1, 2, 4 plus 6 is 10 carry 1. 100.23 should be our molar mass for heptane. Over on this side, we know that the temperature change was 13.2 degrees. We're trying to find C, and we don't know the total energy yet. So not a lot we can do on the calorimeter side, but we should be able to do something here. If we know our mass and molar mass, we can get the number of moles for heptane is 1 gram divided by 100.23. I just saw my calculator. Where is it? Okay. 1 divided by 100.23, 0.009977 moles of heptane. Our reaction enthalpy is going to be N times delta H, so it's this number I just said times 4816.7. So burning the heptane will release 48.056, that's probably enough, kilojoules of heat. And the reason I did all the color switching here is just to remind you, the heat that comes out of this side of the reaction is exactly the same as the heat that goes in here. It's like an accounting transaction where you spend a certain amount of money, the merchant makes that exact same amount because it's the same money we're talking about, just from two different sides. So now, over here, this total enthalpy, we can write 48.056. 48.056 kilojoules equals a C I don't know times 13.2 degrees Celsius. Divide both sides by 13.2, and we get that the specific heat of the calorimeter is 3.641 kilojoules per degree Celsius. Joules per degree Celsius is also acceptable, but because they gave this first information in kilojoules, I just stayed with that. Significant digits, 3, 3. Yeah, lots of our givens only had 3 sig digs, so really 3.64. Let me just trim that down. Would be the right number of digits. That's how you do that. Not all that different, really, but we wanted to remind you that the calorimeter formula exists and it could strike at any moment.